Welcome to part 3 in the controlling and automating a model railway with OpenLCB. Setting up a basic node for CAN bus, no soldering required. So to be able to make any of my basic series nodes, you will require an ESP32 Dev Kit 1. I also recommend we use one of these shields here, and you'll also need this type of transceiver here. This is the SN65HVD230, and I'll show you the 4 connections you need to make now. Okay, so here you can see the shield. Now the first thing that I'm going to point out is it's important to set the 3.3 volt jumper setter, which is here. If you don't, what you'll end up with is 5 volts on this rail here and here. Now we're going to plug in this transceiver unit here, which is a 3.3 volt compatible only. So if you left this at 5 volts, you've destroyed this chip on board here. So with that in that position, you can then power the ESP32 from this 2.1 barrel jack. Now in my case I use 12 volts to do the powering. So what you'll see here, we've got 3 volts, ground, RX and TX. Now I'm going to suggest you buy 100mm DuPont connectors, female to female. You can use longer ones, I wouldn't go too long. Obviously this here has screw terminal holes that you can use for mounting. These do not. However, there's no soldering required, so what I tend to do is I screw these down to a 3D printed base, and this I just hot glue in place, and that holds it. So what you can see here, we've got our black, which is ground, so it's on this rail here. We then have the red, which is on the 3.3 volt rail. We then have the blue, which is RX, going to pin D15 on the shield to RX on the transceiver module. Then we have the green, which is on D2, and that goes to TX on the transceiver module. So that is your 4 connections set up. Another thing to be mindful of, it has a termination resistor fitted. Now you only want 2 termination resistors on the bus, and I'll explain that next. So here you can see a typical CAN bus network. In this case I'm only showing 2 nodes, but it's important to have a 120 ohm resistor at each end of the bus. This is here to balance it out to 60 ohms, and this reduces any likelihood of any noise being picked up from outside, from the likes of your DC motors on your locos or whatever. So this is very important. Now in theory we probably can get away with 55 to 60 nodes maximum on our bus, even though you will see some places where it says 110. This might be a case of if you've got a more robust CAN bus network. So we use normally for OpenLCB and LCC Cat5 cabling. Obviously I strip the Cat5 cabling out of its sheathing, and then I use the spare 3 twisted pairs for connecting up my infrared spot detectors. So this is important to make sure that you do follow this type of practice. When you have more than 2 nodes on the bus, you need to remove this resistor from here. Now this can be done very carefully with a pair of fine tweezers or point nose pliers. Very carefully removing it. Just make sure it's the one next to the TX line, and then we use the 2 terminals here to connect up our CAN H and CAN L. So hopefully that's shown you how we can use the ESP32 Dev Kit 1, and I do use the 30 pin version of it, not the 38 pin version. You can pick these up from the likes of Amazon, probably for less than £10. I do buy mine from AliExpress, a lot cheaper. Okay, that's enough for today. Thank you for watching. Bye now.